Hello, welcome back to Oracle DBA tutorial. In this tutorial, we're going to discuss about shared pool. So this is a big picture in the abstract picture of Oracle server. We are discussing about this part of the memory structure. Okay, so in this video, we are going to discuss what are the shared pool and what kind of information the shared pool contain and how to manage shared pool. All right. So let's take an example. If a like say a client is going to give this SQL statement, select star from EMP. So if you go by in the thing that it's going to come, first thing you're going to connect, and when connect we're going to create a dedicated server process. So dedicated server process for this client, assuming that this is running, the Oracle server is running in the dedicated server mode, and then this is a memory structure, and then this is where your data files are there. So in data file, where I have my information about the employee record is available here. So what is going to happen is that the dedicated server is going to check if this thing is if the syntax is correct or not. If the syntax is correct, then number two, if the syntax is correct, it will check if there is an employee table there in the database or not, because we are querying from the EMP table, right? So if EMP table is available, so once the dedicated server is going to get all this kind of metadata information, then what he's going to do, he is going to make a plan. Okay, so let's put another color here. So make a plan how to execute this query. That means how to get the data from the data file and put in the database buffer cache. So that we learned in our previous tutorial. So this block is going to come and then stay here, and once it stays here, and after that is going to dedicated server is going to give you the result of this query. These three steps together is called parsing. Okay, so this is a parsing of your SQL statement. The parsing of SQL statement is saying that if it is compiled, and if the execution plan and all those things together called parsing. Let's say after some time, after we have done with select star from EMP, another user is coming and he is also giving select star from EMP. So if it does the select star from EMP, then what I'm going to do again, Oracle is the user number 2, he has his own dedicated server process, and then let's say this is dedicated server process 2, then this dedicated server process 2 is going to do again the parsing. That means all these three steps which are identical to the user number 1 is going to be redone by the dedicated server 2 for user number 2, because user number 2 is also giving the same query. So this is bad, right? So basically, why you want to reinvent the wheel if the wheel is there? That means, is it possible to reuse the past representation of this query? Like let's say DS1 got this select star from EMP, then if DS1 is doing that, then can we store, we have this memory structure where we are already storing the buffer, database block buffer. So is there any way we can store this past representation in the memory, so that second time whenever this kind of query comes, we will check first in the memory if we can get a past representation. If we get a past representation, then we just going to use that instead of reparsing. You understand my point? So that is what is the goal of shared pool. Shared pool is that area where we are going to store all this past structure of SQL and some PL/SQL, and then some other things. So essentially, shared pool is the area where we store where we cache program bits. Okay, so db block buffer, in the buffer cache, db buffer cache, we are going to store the data. In the share pool, we store the program bits. So in that case, what is going to happen when we're going to, since so in the share pool, we are going to store the parsed value of the select star from emp. In second time, whenever the sum query is going fast, you will check that area and then see if there is a select star from emp equivalent there. Since in this case is there, so therefore we are not going to reparse, we are going to use that parse representation and get the data. And again, that is going to be faster, because I'm not going to do all these steps, and these steps really very CPU intensive, and we will check like if the table is there and all this thing. And also to make a execution plan which optimizer is going to do that for you, that also takes some time. Okay, so all those things can be get out, we don't need to do all those things if we use share pool, and if you keep this thing and shared among different sessions. So that is the concept of share pool. And then share pool is again divided into multiple things, like multiple areas. So as we saw that if you go to this table $SGA start, and if you query select name comma bytes from $SGA start, where pool is equal to share pool. So if you write this query, then you are going to get maybe 200 rows. That means those are the different areas inside the share pool. But the most important areas of share pool we are going to discuss here. So let's say this is the share pool. Share pool is divided into importantly into a part which is called library cache. So this is called library cache. So in library cache, we are going to store the SQL information. Like whenever you do that select star from emp, the parsed representation of this query is going to be stored in this area called SQL area, which is the part of library cache. Okay, the library cache is a part of share pool. Share pool is a part of your SGA. So that is how you can visualize. Then the remaining things, so in the SQL area, what I'm going to have, this is going to contain in the share pool. A share SQL area contains the parse tree and execution plan of a SQL statement. So this is going to contain parsed tree and execution plan of SQL statement. So whenever we're going to do select star from emp, whatever the parse tree and execution session, that is going to take some memory here. Okay, and then let's say I do select star from dpt, then it's going to take some memory like this, and so on. Eventually this area is going to filled. If this area is going to filled, then you are going to use LRU algorithm to release whatever was old, and whatever is new, those things are going to be there inside the SQL area of your library cache. The remaining area is called PL/SQL area. Okay, so the remaining area is called PL/SQL area. So this is where whenever you are running a stored procedure or function, so this is the area to which the parsed value of that PL/SQL procedure is going to be loaded. This is why whenever we discussed about why this PL/SQL is faster, because say for example user number 1 is going to execute a procedure called exec p1. So while he exec p1, this procedure p1 is compiled, parsed and stored here in this PL/SQL area. Next time user 2 is going to run exec p1, he's just going to run this one, and that's going to be very much faster than anything else. Okay, and then the next area is called, okay, so this area is your dictionary cache. So dictionary cache means, as you told you, whenever we are going to do select star from emp, in the second step we are going to see that if employee table is there or not. So that means it has to go to the database to see employee table is there or not. For the first time, if he knows that employee table is there, then he is going to store that employee table is there, that information, in this cache called dictionary cache. So dictionary cache is going to store whatever the data dictionary objects which is being used right now. So for example, if you when you write a query, select star from department, the department tables information, like what kind of constraints are there, what are the names of the columns, what are the null value, and all those things are going to come and then cached here in dictionary cache. Again, this dictionary cache is a limited amount of area, and this is managed by LRU algorithm. Then the next important structure is called control structure. Okay, so this is called control structure. So this control structure is going to keep the lock information. Let's say whenever you are updating something, or if you want to do a SQL statement called lock table T. So this control structure is going to store that this table is locked and what kind of lock is being acquired by that object and so on. So this is the major thing about SharePoint. But as I told you, if you query your $SGStat to find out what are the different components, you will find something else. So don't worry that, because Oracle gives you all, there are a lot of other things which I am not telling you here. Okay, and which sometimes you don't really need that. So if you know how to how much size all these things would be, then you can just basically you'll be fine. You don't need to know all other those small things. But however, sometimes for fine tuning and all those things, you might need those things. We want to explain another important concept called bind variable. So let's try to understand what is bind variable and then how people used to mess it up and then make the Oracle database very low performing. Let's say the query Q1 is somebody is going to give select star from EMP where employee number is equal to 1. So let's say this is the first time. So what's going to happen, that in my SharePoint, in my library cache, I have something called SQL area. So I'm going to, for first time since it's giving, I'm going to compile this thing and make sure that there's employee table there and there's employee number is a column and all this thing, and I will make an execution plan and I'll store that execution plan and the parse structure inside the SQL area. Then let's say question number 2, somebody is going to give select star from EMP where employee number is equal to 2. So this is a second query. So if you see, then the second query comes and then it's try to find out what is do I have a parsed equivalent of this query. That means if the query Q1 and Q2 are same, then they should have a same parse representation and same execution plan. But unfortunately everything is same. Everything is almost same up to this point. But the last character in one case is 1, in another case is 2. Therefore these two queries are not literally equivalent this thing. So that means in this case Oracle is again going to parse this one, even though almost everything is same, but it will have a different value and it will store here. That means we need to parse again. So similarly, like in again somebody is going to give employee number is equal to say 5. So everything else is same, just only that he is going to query the employee number to 5. So again another parsing. So these are called hard parsing. Okay, hard parsing, because it does all this execution plan and all this thing. So what I can do, I can write all this query in a different way. I'm going to write select star from EMP where EMP number is equal to X. So this the user one is going to write this query, and if it's write this query, then the first time, so let's now remove all these things, because we assume that we rewrite this query and we start the database, so therefore nothing is there right now. Okay, and then for the first time when I write this query, this q1 select star from MP where employee number is equal to x colon x, then we create a parse tree and execution plan. In second user is going to do, and then whenever you're going to do q1, then it will in our runtime it will ask what is the value of x, then he gives value of x is equal to 1 because he wants to do 1. Then second user, he is also going to do exactly same query, select star from MP where employee number is equal to colon x. So I don't write, so exactly same thing user number 2 is going to do. But user number 2, whenever is asked for you the values of employee number, he will give 2. By doing this thing, what we are saying, that this query now they are sending q1 and q2, they are exactly same. Therefore they can use, once they parse and keep the parsing execution plan and parse tree, q1 q2 q3 and all those things, they can reuse that one. Okay, and during the runtime they will bind to the actual value of this thing. So this is how you are going to use bind variable, so that your application will scalable. Otherwise, like if you write an application like this without using bind variable, then you are going to be in problem, saying that you will do lot of hard parsing. Okay, so that can be avoided by using a bind variable.